So Google's mission from its founding has been to organize the world's information and make it universally accessible and useful. In doing this, Google has created 8 products, many of which all of you use every day, that have over 1 billion, with a B, active users every month, right? Google Cloud, which is what I'm with, is an organization within Google whose mission is to empower all of you to use the innovations that Google has created over the last 20 years. The most important innovation from my perspective is the AI. In fact, our CEO, Sundar Pichai, declared that Google is an AI-first company. You've seen this kind of talk in the media as well. AI at Google has been exploding over the last decade or so. We have thousands of models that run every day, every second, going to work for you inside all of the products you use. So everything from the flagship product, Google Search, to Gmail, Google Drive, YouTube, Android, Chrome, Maps, everything is driven by AI. Our business is driven by AI as well, Maps, ads, and things like the new things we're doing with self-driving cars and so forth. We also run our operations on AI, so our data centers are controlled by AI, and that's resulted in a 40% reduction of energy consumption in these centers. Google has been carbon neutral for 10 years. All of this AI is enabled by a digital backbone, which is just starting to come of age. So there are things like Internet of Things, IoT, big data, cloud computing, machine learning, and devices and hardware that folks like you are inventing, and so forth. So when you look at the intersection of AI and hardware, I see kind of 3 big places where the game is changing and about to change in a very big way. And they're around interaction, production, and democratization. So interaction is how we create human experiences, how humans interact with our devices and our AI. And as Danielle said, really everything starts with the human experience. Technology or hardware for its own sake is meaningless unless we look at and work back from how it impacts users. So we always start there. What are the new experiences that are being created by digital devices? We then look at production. How are these devices being made? New ways of manufacturing enabled by AI. And then finally, democratization, new ways of doing the AI that drives these devices. Right? It's nice that companies like Google and others have hundreds or thousands of AI scientists with PhDs doing AI, but what does that mean for the rest of the world? How do we enable everybody to do AI? As we'll talk a little bit about these 3 themes in the next 30 minutes. So let's start with interaction. When you think of how devices interact with humans, we have to think about the human senses. We want to be able to not just type at our devices, but touch them, talk to them, see them, interact with them without even directly interacting with them. These devices need to have all of those same senses and modalities that we have. That is sort of the future of human interfaces to devices. So if you give you a quick tour to some of the ways we are seeing this in Google products, and you've seen these in products from other companies as well, things like, for example, Google Search. The biggest driver of search accuracy among hundreds and hundreds of signals that are used for search is AI. You can predict for every user which search results they would prefer in a sea of results with over 80% accuracy. Listening is one of the most important human modalities. Over 20% of our searches are done through voice. And if you have things like Google Home or other devices at home or an Android Auto in your car, you can talk to all these devices. All of that runs on AI. We have to understand your speech. We have to understand the words that you said, what they meant, what you actually meant to find, and then go find you the information and render it back to you very crisply. You can go beyond human speech to just listening. You can build listening devices that can hear all kinds of things. For example, this is a project we're doing with the University of Wellington to listen for bird calls to identify endangered species. So imagine intelligent bird houses, for example. Visual interaction is another big modality. If you're like me, You have tens of thousands of photos in your photo library. I've long given up trying to categorize them and organize them. I don't have to. Google Photos does that for me. Google Photos can look at a scene and tell you what's in the scene. There's a beach, there's a boat, there's trees in the background. And I can say, hey, show me pictures of that beach we went to last year, and up comes the photo. I didn't have to tag it. All happens automatically. So imagine a whole new generation of intelligent cameras. We can do this now, look at the scene and say, that's a person on a beach flying a kite. We can apply this to video as well. You can try this now. You can go online, upload a bunch of videos, and say, hey, show me videos with cars in them. You can type the search or speak to it, and up come a list of videos. You're seeing all of the cars in the videos, and the little red dots over here indicate the frames at which you see cars in those videos. You can also take a single video, and the technology will analyze this and show you that this one has an ocean and water, and later in the video, it has a skyline with a city, and there's a computer keyboard, and so forth. All happens automatically. You can put this in the wild. You can have video cameras that can detect animals. This is a project, another project with wild animals in Africa. And we are getting very, very high accuracy in recognizing these kinds of animals. In fact, the change that has driven this kind of behavior or this kind of capability over the last few years is the vast improvement in image recognition. Less than a decade ago, that scene I just showed you would be recognized with about 75% accuracy, right? Whereas humans can recognize animals at a distance with about 95% accuracy. Fast forward to a couple years ago, we are now better than humans in these technologies. So your cameras, your video cameras, your voice recognition, all of this is now starting to get to human or superhuman performance. You can sketch. Another way we interact is by swiping, drawing, touching. You can try this. You go to Google Quick Draw, and you can start sketching on your screen on your phone, and we'll recognize in real time what you're trying to sketch. Kind of like playing Pictionary, except in real time with a computer. We can also write with AI. So AI is now drives about over 12% of responses on Gmail. And it's not sort of autocorrecting a word, it's actually predicting the whole sentence, what you're about to say. Saves you a lot of effort on a phone, for example. We can combine the video and the speech and the text capabilities, and you get translation. And the interesting thing about this is we can do this with over 100 different languages in real time on this device, on your phone, without Wi-Fi. It's all running on your device locally, and I'll show you in a second how that works. So you can have intelligent devices now that have enough AI compute power in them to do this kind of thing anywhere you go. You can do this with voice as well. You can do now with a few dozen languages real-time voice translation where I speak in one language and you hear it in your own language, like Spanish or Italian. And when you speak back in Italian, I hear it in English. You can do this in real time as well. So put these together, you can now start carrying on conversations with AI, right? So this is where we start to see, what I think will be the next generation of magic. What's interesting about this example is the integration across products. I'm speaking to a phone. Embedded in the phone is Google Assistant. Embedded in that is speech technology, connects back to your Google Photos app, right? So this is not an interaction with one device or one application. This is an interaction across applications. We see a lot of magic with this, right? We see text-to-speech approaching human voice now. So these things can speak back to you, and it sounds completely human. You've probably all seen the duplex demo by now. If you haven't, I'll skip the demo in the interest of time because I want to give time for questions at the end. But if you just search for Google Duplex, you'll be able to see the demo. Basically, the AI now can speak with you in a voice that's completely indistinguishable from a human voice. So simple, natural interactions integrated across experiences that are now everywhere, ubiquitous. Imagine AI in your home. You're sitting at home, you're watching TV, Imagine that same experience. You just say, you don't have to pick up a phone, just say, hey Google, I hope I don't trigger anyone's Google. I generally trigger mine when I say that. Hey Google, show me my photos from last summer at the beach, and the photos show up on your television. It turns on your television, finds your photos, connects it all up, and there you are. You don't have to do anything, right? You have AI in your doorbell. That's the Nest doorbell. It'll announce who's at the door, and it'll even show you a picture of who's at the door on your television. Say, hey, Bill's at the door, if it's someone you recognize. So that kind of integration and ubiquity is very powerful, and I think that's going to be the next wave of AI plus hardware, right? AI wherever you are, in your hands. I can hold up my phone and kind of scan around, and in real time it'll recognize objects as it goes. AI in your car. This is a picture from Waymo, the self-driving car arm of Google or Alphabet. Waymo is now driven over 10 million miles on public roads completely autonomously, and billions of miles of simulated driving as well. That's a picture of the Waymo navigating, and sort of just like I showed you with the phone demo on the previous slide, so recognizing objects as it goes in real time. The big change that happened over the last few years to enable this has again been in this video and sensor fusion capabilities. So as recently as 2015, barely 3 or 4 years ago, if you were driving down a street in a Waymo, this is what you would be seeing. That's not good enough to drive with, right? I wouldn't get in this car if they didn't have a safety driver. Fast forward just 3 years, 2 years. That's what the cars see now. And that's a year and a half ago, right? So you're seeing now very accurate recognition of traffic lights, pedestrians, pedestrian crossings, other cars, and so forth. So this AI is sort of getting liberated is the way I think about it. It's no longer the purview of esoteric applications at Stanford University or other universities or a few companies. It's now everywhere. We all interact with AI every single day, enabled by this whole new generation of AI-enabled hardware. AI is now also changing how hardware gets made, how stuff gets made. So we talked about digital backbone for smart devices. The same digital backbone is revolutionizing manufacturing. We're getting real-time data analytics and connectivity. We're getting the ability to simulate and use robots. We're getting some very advanced production technologies through system integration. We're getting new kinds of human-machine interaction. We're getting new kinds of business as well. So if you think about your production environment, if you're a manufacturing company, as being this sort of ecosystem of highly interconnected data coming in from everything from your production mechanisms, your suppliers, your logistics services, your design teams, your customer experience and engagement teams, your marketing teams, as well as all of the commercial applications and partnerships and products you have out in the market. You have a lot of data coming in. You can connect all of this data through the elements of that digital backbone I show you. So with Internet of Things, you now get data across machines and devices that you can leverage across the entire life cycle of product development. You can then leverage big data and machine learning and some of the AI technologies I showed you to make sense of all of that data, get new insights, and build new kinds of applications. These applications can then be delivered using augmented reality and voice and other more natural modalities, not just to consumers, but even to the factory workers. And I'll show you a couple of examples of this. And the marvelous thing is that all of this can be built on the cloud. You don't have to do the AI. You don't have to build all that infrastructure, right? You don't have to manage all this data. The cloud does it all for you. You don't have to secure it because it's all secure. So you as a production company, as a manufacturing company, can focus on manufacturing and not have to worry about the AI. The AI is there for you to go to work for you. So this is starting to enable a whole range of opportunities. And the way we think about them at Google, we divide them into kind of 4 buckets: the digital thread, digital twin, digital business, and digital workforce. And shown in sort of the blue hexagons are some of the technologies that are available right now that I'll show you in a bit that you can use to enable these kinds of opportunities. So digital thread is connecting all of this data and threading it through and making sense of it. Digital twin is the ability to create a twin of your production systems, your manufacturing systems, your factories, your supply chains. Make a twin of that digitally in a simulation and be able to simulate large amounts of what-if scenarios and improve your production processes. Digital workforce is enabling the power of AI to go to work for your workers when they're on the job. I'll show you a couple examples of this as well. And we are also seeing a lot of enablement of new kinds of business models with AI. Your factory, you're a traditional manufacturing company. In the old days, you would stock your product in a retail outlet, a retail store, and people would pay for your product. We can now enable all kinds of new business models because of the AI. So give you a couple of examples with digital twin, for example. Here's a company from, an example from one of our partners where we've done a lot of optimization of operations using simulations that are driven by AI with massive amounts of benefit in terms of revenue, in terms of time saved, in terms of productivity. There's a YouTube video on this if you want to see more detail. This one is interesting to me because it's an example of a new business model, preventative maintenance in the field. It's not only that you can get data from multiple, in this case, trucks on the road to manage your fleet more efficiently, but you can also offer as a service to your customers preventive maintenance, field optimization, and some of these things that you might do. In the old days, they would just lease trucks from you. Some examples of digital workers, you can have, for example, this worker's wearing a Google Glass and being able to get relevant information automatically without having to pull out a smartphone, take off their gloves, and sort of type through an app to find information. This is being used at LG, for example. If you look at for visual inspection of products as they're made, with the current computer vision solution, we're getting about 60% accuracy. They were getting about 60% accuracy, and so humans who had to double check, et cetera. Remember the picture of the cheetah that went from 75 to better than human performance? With AI now, 99.9% accuracy. It completely changes the game if you're a manufacturing company. Millions of dollars, tens of millions of dollars of savings a year. And I'll show you the edge TPU in a minute. Again, just like I showed you with my phone, one of the reasons that this is making a change is the ubiquity, the fact that these technologies are available on the spot. They can be put in your cameras, in your machines. They don't just have to live in the cloud. There's actually sort of a version of the edge TPU in my phone that lets me do real-time translation or photo recognition, et cetera, in real time by running complex AI models right on the device. You can do that in a factory. So the third part then is the democratization. How do we do all this? This AI all looks great, but how do all of you use it? How do you use this? How do you leverage it for your own business? So to see that, let's start with just a quick tour of how AI works, and apologies to all the AI gurus in here. But just to kind of level set where we are at, AI has gone through a series of transformations over the last few decades. We started with this idea that AI was about stuffing a computer with everything we know, with all of human knowledge. We'll just go start building in, Daniel's nodding, you were back in the, right, you've seen this. You start writing rules for example, spam detection. You might write procedures for image recognition if you're building Google Photos, et cetera, writing code. The problem is this, we know too much. Putting all this into a machine and then managing it and maintaining it as things change constantly is an unsurmountable task. I mean, for every spam detection rule we write, there's a young hacker much smarter than us who finds a way to defeat it. So those are the kind of the bottlenecks, the engineering and management of the software and the knowledge that underlies it. So the idea of machine learning was, well, let's have the machine learn this. For example, if you're doing photo recognition or image recognition, We'll feed it the raw data of, in this case, the Eiffel Tower. We'll write some code to extract key features of images like lines and blobs and circles and colors and so forth. And then we'll feed it to some kind of a classifier that'll tell us whether this is or isn't an Eiffel Tower. That works great, except you spend an enormous amount of time feature engineering. What are the right set of features for a robot on the assembly line to pay attention to know if a part is damaged? What are the right set of features for my smart camera to pay attention to recognize that this is a picture of a beach? Or to talk with you about in a customer service environment, right? So very, very hard problem. So deep learning, which came on the scene, so really took off really less than even a decade ago, tackled this problem in a unique way. The idea was to say, let the computer figure out even the features. We'll just feed it the raw data, it'll do something, and out comes the answer. You have to do nothing humanly. So this is how deep learning works. It's sort of loosely modeled after the human brain. You build, it's called deep because you have these layers. You build these layers of very simple computing units. They're called neurons, again, in sort of allusion to the human brain. They're a little different from human neurons, but share some of the properties. You feed it all of the input. Every neuron looks at just the local information around it, computes a very simple mathematical function, and passes on its answer to the next layer, which does the same thing and does the same thing, and eventually you get an answer. In this case, that was a dog in your laundry basket. And again, as I showed you with the cheetah, these things are actually more accurate now in many cases than human vision. So when you want to do AI, you take this new technology with deep learning. Maybe you mix in some of the older stuff as well. You still need knowledge. You still need machine learning. You need sort of 4 key things to do this AI, to do the kind of products I just showed you. You need data, a lot of data. Data about your products, data about the users, data about how your users are using the product. The data may be batch data all at once. It may be streaming. It may come in as you go, like you're driving a car. Structured, unstructured, there's data everywhere. It's all about data. You also need models. You need to make sense of this data. A model is basically what this deep neural network learns to capture the essence of the data for you. So you have DNNs, deep neural networks. CNNs are convolutional neural networks, which are the networks that do spatial convolution. They're used for example, image analysis, like the cat-dog example I showed you. RNNs are recurrent neural networks. They're used for temporal problems, sequential problems, like speech, like driving, like production. You have to deal with speech and vision, language, right? So you need a lot of these models. All of this data, all of these models, they have to be secured. They have to live somewhere at massive scale. They have to be safe. They have to be secure. They have to be replicated in case there's a disaster. You have to so make, because this is important data for you and your customers. And then finally, you need a lot of infrastructure to run the training for these models. It's nice that they learn stuff on their own, but if you imagine the huge amount of information we take in visually and orally, et cetera, every day, and make sense of that, right? It takes a lot of data, a lot of time, a lot of training. We need massive amounts of infrastructure to run this. So Google does this. This is how kind of Google makes sense of all of this for those 8 billion user products and many others approaching 1 billion. We've built what we call a planetary scale computer. This is one of the nodes in the planetary scale computer. It's the size of a small town. It's a data center. If you go inside one, you'll see banks upon banks, racks upon racks of high-powered servers. They're all built from the ground up. They're purpose-built. They're not off-the-shelf machines we buy. And they're connected across the world in a massive network. Google actually carries about 25% of the world's internet traffic. The public internet is not reliable enough and fast enough for the scale at which Google needs to operate. So a lot of it is done through our own network, and then we jump onto the public network at the endpoints when we have to actually get to your phone, let's say. We do this AI at massive scale, again, using these banks. We also do it at a micro scale. So if you think back to my phone that has a chip in it, we also have technology to build very small, very fast models that are almost as good as the massive scale ones that can run on a device. And there's public information on this if you're interested in reading some of the technical details. The devices then we use are called TPUs, tensor processing units. A tensor is just a mathematical representation of a vector that underlies a neural network. And these things are now available even in, you can get them on a USB stick or on a board or on just a chip. And again, as I mentioned, they can be put into phones or cameras or really any smart device you want to build. So deep learning sounds like magic, right? No knowledge engineering, no feature engineering, learns everything. Any bottlenecks with deep learning? What's the big problem here? Yeah, you need data, but you have compute from places like Google, right? It's called architecture engineering. You have to configure these networks. The network, the cat-dog network I showed you is super simple. In reality, these networks get very, very complicated. You need a huge amount of expertise to configure these networks and train them and tweak all the little parameters and figure out exactly what the transfer functions are, et cetera. Requires deep expertise to do deep learning. That's Jeff Hinton. He's one of the founders of deep learning. There are not enough Jeff Hintons in the world, even for Google, let alone for the whole world. So what do we do? So our teams are focused on what we call democratization of AI. Can we make AI available not just to the few thousand deep learning researchers, but the millions of data scientists, the tens of millions of developers out there? We do this through what we call the Cloud AI platform. We make the AI infrastructure available to you. The compute, the storage, the networks, all of the stuff you saw in those pictures, you can have them too. You can use them. We make the same tools available to you that we use, tools like the machine learning engine and BigQuery. TensorFlow, which we've open sourced, is the most popular deep learning framework. And we also make AI available as a service. If you don't want to even deal with TensorFlow and machines and all of that, but you want to do photo recognition, you can actually just use the same thing we do in our products. And it's just an API call away. Right? So the way you use this is you sort of pick the building blocks you need and plug them together into the workflows you want. So if you have an IoT type application, there's your device on the left, there's a module that'll connect these back into the cloud, and you can use things like PubSub, Dataflow to get real-time data, feed into a machine learning engine, and outcome the data you want. It's just like building blocks. We call it build your own AI loop, and we have some tools for data ingestion, processing, database, analytics, and the whole shebang. And there's a bunch of companies using it, some of the ones I showed you earlier, many other names, thousands of people using our products to do the AI that I showed you that we do internally. So at Google, we have this saying, if you do something successfully, you're always challenging yourself to think 10x bigger. How do we 10x this? Okay, so it's great that we can reach 20, 30 million developers. What about the hundreds of millions of business users who are not software engineers, have never written code, don't want to write code? What about the billions of end users? Could any user using a product do AI for themselves? So we built a system called AutoML, which is a system that does AI for you. It can create AI models actually better than experts can. If you think back to AlphaGo, the Go playing program that defeated the world champion, AlphaGo 0 is AutoML learning AlphaGo. It starts with, you just let it go. In about 3 days, it gets to be as good as AlphaGo, which is built with months of effort by a team of experts. And in less than a month, it's performing better than any known Go player, completely autonomously. So that's the power of AutoML. The idea is that we can now use this for other domains as well. So I mentioned energy reduction. AlphaGo, AutoML learns to reduce energy in this cooling center in this data center by modeling energy consumption as a game, and you win the game by reducing energy costs. And it learned to reduce energy costs by 40% over the best tuned, handcrafted power management systems created by experts. So democratizing AutoML, right, is another block in the platform. We are now making that available to you everywhere you are. You can run this in your browser. You can fire up a browser on your phone. Can be a browser from any company. For example, if you want to do image classification, you upload a bunch of images, you hit the train button, it ships this into a neural network that's actually running on that same massive infrastructure I showed you. Out comes a fully trained machine learning model. All you had to do was upload a file and click a button. We have high schoolers doing this. AI in your database. You can write SQL with AI commands like create model and predict embedded in the SQL. It does the AI, it does all of that magic, all of the deep learning for you behind the scenes automatically. AI in a notebook. You can, just like you open a Google Doc or a slide or a spreadsheet, you can open a notebook in which you can put in both text as well as AI commands to do AI. AI in a spreadsheet. Imagine you have a data warehouse with 100 million rows. You can go online, the 2 or 3 clicks of a button, connect it into a spreadsheet. Go to your Google Drive, you see a Google spreadsheet there, except this spreadsheet has 100 million rows. And you can then ask it a question. You can say, show me my performance or performance by week, and it writes the code for you, does the AI, and it shows you the graphs you need. Anybody can do this. So by democratization, this is my last slide now, what we mean is, let's empower everybody to put AI into the things. You guys are all making all kinds of nice hardware that I can't wait to try. You can put AI in this as easy as clicking a few buttons, connecting a few blocks, and enable the kinds of magical interactions and also reduce your costs at the same time by producing these devices using new manufacturing techniques. Okay, so that's it. If you want to try any of this thing, cloud.google.com. There's a very generous free tier. You can go try it for yourself. Everything I showed you is completely available. And that's my handle if you want to get in touch with me. Thank you very much, and I think we have a few minutes for questions.
Thank you, Ashwin. You know, so I think we can take one question, and then Dr. Ram is actually going to